Okay, so I'm glad you joined me for part 2 of this two-part video um, review for the Chapter 7 test. So we'll pick right up where we left off from, another inverse problem. It says find the inverse and verify, and we're going to take a look at this function, f of x equals x squared plus 3. And notice they put this domain right here, okay? This guy right here, this is a domain. Now, we need to understand that this is a quadratic, which is a parabola. So if we come over here and graph it, this 3 makes our point at 0, 0 go up 3. And then it's just the parabola that opens up. So it looks like this. Now notice that this graph right here, if I drew a horizontal line through the graph, right, fails the horizontal line test. But when we restrict the domain, so we include only the x's greater than or equal to 0, that's just this part, the orange part. And now the horizontal line test will pass. So this can have an inverse. So we need to keep that keep that in mind as we go through find the inverse. Remember that this means positive numbers as well. So when we find our inverse, we might have to use that fact. Okay, so same process as the last problem. So we let y be f of x. We replace x and y, and now I solve for y. Subtract 3 from both sides. X minus 3 equals y squared. And we are going to take the square root of both sides, because when you take the square root, that cancels the squared and gives you y. Now, when you take the square root over here, you should put plus or minus in front of it. However, this would give you two curves. The plus would give you the one that goes above, and the minus would give you the one that goes below. You only want one, so you take into account the domain, and you say, okay, I just want the positive. I don't want the negative. So your inverse function for this quadratic, for this x squared, is going to be the positive square root of x minus 3. So again, understand squareds and square roots are inverses, cubes and cube roots are inverses, right? So they have this index to power relationship. So now let's verify. Well, to verify, we have to find two things. We have to find, and I'll use a different color, let's use red, f of f inverse of x, and the other composition. So we'll do f of f inverse. F inverse is the square root of x minus 3. I'll plug that into f. I will not put the x, I'll put the squared plus 3. And in place of the x, I put this guy, square root of x minus 3. And I'll put in parentheses. And what happens when you square a square root? They cancel. And we get x minus 3 out of the square root, and the plus 3 comes down. Minus 3 plus 3 cancels, and there is your x. That's what you want. Every time, verify, get x. Okay, now let's do the other one. F inverse of f of x. That's f inverse of, we put f of x in there, x squared plus 3. And I will write my inverse function, square root of, do not put the x, put the minus 3, and x squared plus 3 goes in that place. The plus 3 and minus 3 cancel, so that gives you the square root of x squared, and the square root and the squared cancel and leaves you with x. And you have verified that these are inverse functions. Okay, very good on inverse functions. Okay, last section of problems we're going to do 4 are all solving problems, and they will involve rational exponents and radicals. So here's our problem. X to the 4/3 minus 5 equals 11. We will get the x to the 4/3 alone by adding 5 to both sides. And now, when you want to get rid of the reciprocal power, or when you want to get rid of the rational exponent, you will raise both sides to the reciprocal power. The reciprocal of 4/3 is 3/4. And we do the same thing over here. The 3/4 cancels with the 4/3, leaving you with x. And I will do this on the side. 16 to the 3/4 is the 4th root of 16 cubed. The 4th root of 16, 16 is 2 to the 4th. So it's 2 cubed. And 2 cubed is 8. So there's my supposed answer. But remember, with all these indexes and stuff, you have to always check. 8 to the 4/3 minus 5. Well, this is the cube root of 8 to the 4th. The cube root of 8 is 2. 2 to the fourth is 16. And 16 minus 5 is 11. And you're good to go. So 8 is my answer. Okay. Next problem is going to say 2, parenthesis, x plus 1 to the 3/2 equals 54. Alright, so now I want to get this guy by itself, right? Because it's this quantity raised to the exponent. So let's divide by 2. Let's get rid of that 2 in front. We get x plus 1 to the 3/2 equals 27. And now, to get rid of this 3/2 power, I'm going to raise it to the reciprocal, 2/3. And I'll do it on this side as well. So the 3/2 and 2/3 cancels. The parenthesis also drops, x plus 1. Over here, 27 to the 2/3. That is the cube root of 27 squared. The cube root of 27 is 3. And 3 squared is 9. So this number is 9. And we subtract 1, and again, we get the number 8. So I think that's my answer, but I would like to check first. Always check. I will plug it into the left side. 2. 8 plus 1 is 9, so it's 2 times 9 to the 3/2. That is just going to be, and we decide that 9 to the 3/2 is going to be the square root of 9 cubed. Right? That's what 9 to the 3/2 is. This is going to be 3 cubed, which is 27. So this is just 2 times 27, which is 54. And 54 is what we wanted, so 8 is our solution. Okay, so those are the rational exponent examples. All right, now let's move on to radicals. So let's try this one. This one says the square root of 3x plus 1 minus 2 square root of x minus 5 equals 0. So remember the rule. The rule is 1 radical per side. So I'm going to take this minus 2 square root of x minus 5, and I'm going to add it to both sides. So I'm going to add. And what we get is the square root of 3x plus 1 equals 2 square root of x minus 5. And we really can't do anything with this 2. It's just got to kind of stay here. So we're going to get rid of the radicals by squaring both sides. So we'll get 3x plus 1 over here equals, and on this side, that 2 gets the square. Okay, you have to distribute the square to the 2 and the square root. So it's going to become 4 times the square root and the square cancel, x minus 5. So now we have 3x plus 1 equals over here 4x minus 20. I will subtract 3x from both sides, so I get 1 equals x minus 20, and I will add 20 to both sides. 21 equals x. So there's my supposed answer. Let's check to make sure. I need to plug it in here. So we have the square root of 3 times 21 is 63. Minus 2 times the square root of 21 minus 5 is 16. That should come out to be 0. Square root of 64 minus 2 times the square root of 16. So let's see. Square root of 64 is 8. 2 times the square root of 16. The square root of 16 is 4. 8 minus 8 is 0. And there's our answer. Okay. So be careful when you have that 2 out in front that you square it as well. Okay. And again, 1 radical per side. Okay. Last problem coming. Square root of 3x plus 13 equals x plus 5. We have the square root on one side, so we are going to square both sides. Notice what I do on the right side, x plus 5 in a parenthesis, because we need to do x plus 5 times x plus 5, and FOIL this out. X squared plus 5x plus 5x plus 25. x squared plus 10x plus 25. And that is going to be our right side. X squared plus 10x plus 25. The left side, the squared cancel. 3x plus 13. Move everything to the right side. Subtract 3x, subtract 13. Subtract 3x, subtract 13. Gone, gone, 0. You need 0. You get this quadratic look, you need 0. X squared plus 7x plus 12. All right. And here are our here's our quadratic, I'm sorry. So we need to FOIL, reverse FOIL, or factor this. 2 sets of parentheses. Positive C means same signs. So now look here at B. B is positive, so they're both going to be positive. There is no A, so it's just X and X. And I'm looking at my factors of 12. My factors of 12 are 1 and 12, 2 and 6, 3 and 4. Signs are the same, so I'm looking to add to get 7. That's 3 and 4. 3 and 4. So we set each of those parentheses equal to 0. X could be negative 3, or x could be negative 4. But I do need to check. I need to check to verify that both work. So the check. 3 times negative 3 is negative 9. Negative 9 plus 13 inside the square root should be equal to negative 3 plus 5, which is negative 2. This is the square root of 4 equals, sorry, going too fast. It should be a positive 2. Okay, that's a positive 2, not a negative 2. So the square root of 4 is 2. That checks out right. So negative 3 works. Okay, we plug in negative 4. Negative 4 times 3 is negative 12. So negative 12 plus 13. That equals negative 4 plus 5 is 1. This is the square root of 1, and the square root of 1 does equal 1. Checks out good. And there's another solution. Remember, you must always check, because especially in these problems, one of the answers might cross off. If not, maybe 2 of the answers. Okay? If you crossed off both answers, your answer would be no solution. So remember that. Okay? So hopefully this helps you prepare for that Chapter 7 test, and gives you kind of a reminder over spring break. All right. Thanks for watching.